IITJEE.
Hi, Barry Science Lab!
Alright folks, so let's check out this question about the relationship between acceleration and distance. So you start from rest and you accelerate with a given constant acceleration for a given distance. If you repeat the process with twice the acceleration, then the time required to travel the same distance, and what happens to the time? That's the question. So this is a really cool question, right? So what happens, you have two scenarios. Number one, you start from rest, right? So your initial velocity is 0, and you accelerate with a given constant acceleration, let's call it a, for a given distance. Let's call that distance d. Okay, for our next scenario, the problem asks us to consider if we repeat the same thing, but with twice the acceleration. So instead of a, I'm going to say 2a, then the time required to travel the same distance would be how much? AKA here, there's a time t elapsed. Here, what would happen to the time, right? The time is going to be multiplied by some constant factor k. Now that k can be less than 1, in which case the time will be less than what it was before, or it can be greater than 1, in which case it will be more than what it was before. Now, if you have twice the acceleration, it makes sense that the distance would be, the time required to travel the same distance should be shortened. So obviously the answer cannot be doubles or remains the same or increases. The time either is halved, which might make sense since you double the acceleration, or the time might decrease by a factor of root 2. Now, many people would just take this to be true, it's halved, and go on with their lives. But the thing is that the relationship between time and acceleration is not so linear. Let's see what I mean by that. If I have distance is equal to VIT plus half AT squared, you can see directly what I mean. My velocity initially is 0, so this factor goes to 0. I'm left with distance is equal to half AT squared. So what's my time? My time is going to be square root of 2AD. Now, I want to travel the same distance, but with double the acceleration. So let's do that. The same distance, but now I'm going to double the acceleration. So half 2a t squared. Now let's see what happens. Well, the 2's cancel out. I'm left with d over a. Whoops. Is it frozen? Yep. You're just seeing a blooper in real time, folks. Let's refresh that. All right. So let's get back at it. Right. So what's my distance going to be? Well, my distance is going to equal a t squared. So my time is going to be d over a. Root that. That's my time. Here I made a little typo. I'm sure you noticed. Here's the time is not root 2ad. Instead, I have 2ad equals t. Okay, whoops. I have 2d over a, I should say. 2d over a. 2d over a. Root that, and I'm going to get my time. So what do you notice is the difference between these two? Well, you see an extra factor. You see a factor of not 2, but square root of 2. So what's our answer? Our answer is going to be choice E. Thanks for watching this episode of Physics. Hopefully this helped. If it didn't, leave some comments. We'll get right back at you.
Embedded plus MKO plus scaffolding equal learning. We believe anyone can learn anything. That's why our motto is memorization is a crime. And that's why we partnered with Brilliant.
Brilliant transforms math and science into hands-on activities so that you too can understand everything from first grade math to E equals MC squared. Barry Science Lab and Brilliant is your MKO and will give you the scaffolding to expand your ZPD until you become the next Sir Isaac Newton or Albert Einstein.
Visit brilliant.org/Barry Science Lab today. And the first 50 of you to use that link will get a 20% discount on the Brilliant annual subscription.
Don't forget that you too can become the next Einstein. So let's fall in love with math and science.